Hi everyone, today we're going to look at permutations with special conditions or with repetition. But first let's warm up from the last lesson. I'd like you to copy these two problems and work on them. The first one reviews factorial notation, so rewrite that quotient without factorials, and the second one reviews the NPR notation. Okay, try that. All right, so for the first one, we could write the first out as a product 2n, which is the first factor. Then we keep subtracting 1, 2n minus 2, 2n minus 1, 2n minus 2. And then we have 2n minus 3, etc., factorial. And the bottom is just 2n minus 3 factorial. These simply divide through. So the answer here is just 2n times 2n minus 1 times 2n minus 2. Okay. In the second one, we discussed the formula for NPR, and there were two formulas. We start with n, and we count down until the last factor is n minus r plus 1, okay? Or we could say that we have r spaces, so in this case, we have two spaces, and we count down from 15, 15 times 14. And in this case, 15 minus 2 plus 1 gives us the 14. But we don't really need that formula. All right. Now, okay, so we want to know what this left side would be. So 15 times 14, when we multiply, that gives us 210. So we have to count down from 7 and see how many spaces must we fill so we would get a product of 210. Well, let's start counting down. 7 times 6 would give us 42. And if we take the 42 and multiply it by 5, we get the 210. So the correct answer is 7p3 is equal to 15p2. So n in this problem is equal to 3. Okay, let's just review another formula for NPR that we discovered was n factorial over n minus r factorial. And NPN, we said, is equivalent to n factorial. And if we substitute r for n in this formula, we get n factorial over n minus n factorial, which would introduce a 0 factorial. And for that reason, because we want NPN to equal n factorial, we define 0 factorial to equal 1. So I did mention that in the last video, but this is a nice way to show it. Okay, let's move on to permutations with and without repetition. All right, so problems 3 and 4 are alike, except there is a big difference between the two words. In number 3, we want to know how many different four-letter words can be formed from the letters in the word CALM. And the word doesn't have to make sense. For instance, I could have an arrangement like LMCA. That's not a word, but that's considered an arrangement. Well, we have 4 different letters, and we're filling 4 spots. So there are 4 ways to pick the first spot, which is the C, A, L, or M. Once one letter is picked, there are 3 choices for the second. Once those 2 letters are picked, there are 2 choices for the third. And then the last is predetermined. So this is represented by 4 factorial ways, or 24 ways. But the word lull is also a 4-letter word, but notice that 3 of the letters repeat. So we could actually list the 4-letter words in the word lull. They could be lull, L-U-L-L. We could have L-L-U-L, and L L L U, and finally the last one would be U L L L. And I think that's it. Those are the words, so to speak, that we would get. But notice that because the L's are alike, it doesn't matter where we put them. And our answer is 4 ways. So how can we get this 4 using a permutation with 4 distinct letters, namely 4 factorial? Well, when the letters were distinct, we had 24 ways. When 3 of the letters repeated, we had 4 ways. We have an extra factor of 6. Let's see where that factor of 6 came in. Well, let's make lull into a 4-letter word with 4 different letters. And the way we could make the letters different is to subscript them. I could put L1, L2, L3, L1, L2, L3, L1, L2, L3, and L1, L2, L3. So if now I should have 24 ways because I've just created a word, or I just found a word with 4 different letters. So for each of these particular cases that I've listed, each of the 4, we can write down the permutations because now the L's are different. So I could write L1, U, L3, L2. I could switch these 2. I could write L2, U, L1, L3, and then L2, U, L3, L1, and then finally L3, U, L1, L2, or L3, U, L2, L1. And notice with this particular case, when the L's are different, I have 6 extra arrangements here. All right, I'd like you to do the same for the last 3. Now, I'd like you to list the permutations for this case, and that case. And we should have a total of 24. Okay, pause the video and try it. Okay, so I listed the other possibilities. I think I included everything. Let's make sure. So notice that I tried to keep the order. So when the L's are different and they're subscripted L1, L2, L3, notice that each of these had 6 cases. So now we've listed the 24 permutations just as if lull had 4 different letters, just like the word come. All right, so where did this extra factor of 6 come in? Well, what is 6 in factorial notation? 6 is 3 factorial. It's 3 times 2 times 1. And the 3 factorial would imply that we're arranging 3 things as if they're different. What are these 3 things that are different? They are the L's. Notice that when we listed all 24 outcomes, we are basically rearranging the L's. And the additional rearrangement was a factor of 6. So that 3 factorial represented the number of ways to permute 3 different letters. And in this case, it was the L's. So to get the answer to the problem using factorial, what we would do is we would pretend that LULL was a 4-letter word with different letters, so there are 4 factorial ways, but we would have to divide it by the number of ways to permute the repeating letters if they were different, and that would be 3 factorial. So notice that this would give us 4 times 3 times 2 times 1 divided by 3 times 2 times 1, and we get our answer of 4. So this leads to a very important formula. In general, the number of permutations of n things taken n at a time with r things identical is given by n factorial divided by r factorial, which is really interesting. You're treating the things that are alike differently, and you're dividing by the excess number of permutations formed by the repeating letters as if they were different. Okay, so let's try another one. So we'll call this number 5. How many different four-letter words can be formed from the letters of the word baby? Okay, well, we know that if this was a four-letter word with four distinct letters, there would be 4 factorial ways to permute them. But we have to divide by the number of ways to permute the B's if they were different, and that would be 2 factorial ways since the B's repeat twice. So that would give us 4 times 3 times 2 factorial over 2 factorial, which would give us a total of 12 ways. Okay, let's try another. And before we go to the next problem, I've listed the 12 ways, the 12 so-called words that can be formed by the letters B, A, B, Y, and the B's are alike. All right, let's take a look at these two. How many different 6-digit numerals can be written using all of the following digits? 2, 2, 2, 2, 3, and 5. So we have 6 digits, a 6-digit numeral. So if we had 6 different numbers, there'd be 6 factorial ways to arrange them. But because we have 4 repeating 2's, we divide it by 4 factorial. So the answer would be 6 times 5 times 4 factorial over 4 factorial, and the answer is 30 ways. So remember, this is the number of ways to permute the repeating 2. 4 factorial ways, since there are 4 of them. So it's important to find the number of times something repeats. All right, now in the next one, we want to see how many different 7-letter words can be formed from the letters in the word divided. Now, this word is different from something like lull or bubble. Here, notice we have 2 repeating I's and 3 repeating D's. But if these were different letters and I had a 7-letter word that had all different letters, there'd be 7 factorial ways to permute that. However, the D repeats 3 times. So we have to divide that by 3 factorial ways to permute the D's if they were different. We also have the I that repeats 2 times. But we have to divide that by 2 factorial. But the question is, what do we do with these 2? Do we multiply them? Do we add them? Do we subtract them? Well, let's go back to that very special word. Since we're going to permute 3 D's and 2 I's, by the counting principle, we multiply. So the answer is 7 factorial divided by 3 factorial times 2 factorial. And if we work this out, we get 7 times 6 times 5 times 4 times 3 factorial, all divided by 3 factorial times 2 factorial. I didn't write out the 3 factorial. There's so many ways to do this. These divide through. The 2 goes either into the 4 or the 6. I'll make it go into the 4. And when we multiply this out, our final answer is 420 ways. So we could have many letters that repeat. So let's look at another one. Now let's find the number of distinct arrangements of the letters in the word Tennessee. Okay, try this by yourself. Pause the video. Okay, so the word Tennessee has 9 letters, and if we had 9 distinct letters, there would be 9 factorial ways to rearrange these. However, Tennessee has 4 E's, so we divide by 4 factorial. 2 N's, so we multiply that by 2 factorial. And 2 S's, so we multiply that by 3 factorial. So the number of ways to permute the 4 E's and the 2 N's and the 2 S's when they are different would be 4 factorial times 2 factorial times 2 factorial, which would go into the denominator. Now let's simplify this. So if we write this out, the 9 factorial can be written as 9 times 8 times 7, 6, 5, 4 factorial, divided by, and I left the 4 factorial alone in the denominator at the end, and I rewrote the 2 factorials. The 4 factorials divide through, and the 2 times 2 is 4, which divides into the 8 twice, and the final answer should be 3,000. Okay, I hope my arithmetic is correct. 3,780 ways. Okay. All right. So that takes care of permutations with repetition and without repetition. And then, of course, we have the permutation problems that have certain restrictions or conditions. Let's take a look at one. All right. Now, these next 2 problems are permutations with restrictions. So let's take a look at it. Number 9, how many numbers greater than 330,000 can be made from the digits 1, 2, 3, 4, 5, 6? And let's assume that the digits cannot be repeated. And the next one is, in how many ways can 5 girls and 4 boys be arranged on a bench if no 2 girls sit together? All right, try these and let's see what we get. All right, so if the number has to be greater than 30,000, well, the first digit could be a 3 because the next digit would have to be something other than 3. 1, 2, 4, 5, 6. So if it's a digit greater than 30,000, then there is one way, well, there are actually 4 ways to pick the first place. We could pick the 3, the 4, the 5, or the 6. All right. Now, once we pick the first digit, which is 3, 4, 5, or 6, one of those digits are taken. So we have now 5 digits left for the second place, 4 digits left for the third place, and so on. If we're going to use all 6 digits, 1, 2, 3, 4, 5, 6. So whatever that answer would come out to be. All right, so the restriction was the first digit. Once we fill the number of ways, first fill the restrictions. Once we fill the number of ways the restrictions can occur, we consider how many are left. All right, so we're going to see 5 girls and 4 boys. So we're going to sit 9 people. 1, 2, 3, 4, 5, 6, 7, 8, 9. And of course, we multiply by the fundamental counting principle. All right. So in how many ways can 5 girls and 4 boys be arranged on a bench if no 2 girls sit together? In a problem like this, it's a good idea to actually list the arrangement to see what it would look like. So one way to seat 5 girls that are not next to each other, and I think it's the only way in this case, is to start with a girl and alternate girl, boy, etc. If we had done this, started with the boys, then there's a problem. We're seating 1, 2, 3, 4 girls and 5 boys. So in this case, this is the arrangement we're looking for. So let's list the possibilities. Okay, so we have 5 girls for the first spot. Once she sits down, 4 for the third. Once the 2 of the girls sit down, we've got 3 for the middle spot. And then finally 2 left for this spot and 1. So these are the girls. As far as the boys go, then we have 4 choices for the second spot. Once he sits down, 3 for the fourth. Once those 2 boys sit down, 2 for that spot, and finally 1 at the end. So this would be our answer. And if we multiply this out, we get 2,880 ways. But what I would grade, I would be worried about these factors, the factors that we've listed, because that's the key. All right, let's take a look at another. Okay, this is our last problem. Using the letters in the word radius, tell how many 6-letter permutations with no repetition are possible if the first letter is an R, the first letter is a vowel, the first 3 letters are vowels, or the vowels and consonants alternate beginning with a vowel. All right, so we are rearranging the letters in the word radius, and we're using all of them, 2, 3, 4, 5, 6, with restrictions. All right, the letters don't repeat, so we don't have to worry about that. So the first letter has to be an R. There's one way to fill that. Just pick the R. But we've got 5 letters left over, so we have 5, 4, 3, 2, 1 ways, or 5 factorial, because the first letter was predetermined. If the first letter has to be a vowel, well, there are 3 vowels to pick from. There's A, I, and U. But once a vowel is picked, there's still 5 letters to choose from. So we have 5, 4, 3, 2, 1. So the answer would be 3 times 5 factorial. If the first 3 letters have to be vowels, there are 3 vowels, so there are 3 ways to pick the first one, 2 ways for the second, 1 way for the third. We used up 3 letters. We've got 3 letters left over, so we have 3 times 2 times 1. So that's 3 factorial times 3 factorial. And we have a vowel and consonant alternating. 1, 2, 3, 4, 5, 6. Well, we have to start with the vowel. So there are 3 vowels. So for the vowels, we have 3 for the first, 2 for the middle, 1 for the fifth. And then because we used the 3 vowels, we have 3 left over, and we have 3 in the second, 2 in the fourth, and 1 in the last, which I believe is equivalent to the first answer, the part C, I should say. So here we have vowel, consonant, vowel, consonant, vowel, consonant. We could also, well, that would be the answer because they did say beginning with a vowel. But suppose the problem was Suppose they didn't specify which one we should begin with. So suppose they just asked in how many ways or how many permutations can be formed from the letters in the word radius with no repetition possible, and the vowels and consonants alternate. Well, this is a possibility, but also this would be a possibility. So notice we've got two different cases. So in this case, we said the answer was 3, 1, 2, 3, 4, 5, 6. So 3, 2, 1, and then 3, 2, 1. But then we could have this possibility, which is exactly the same thing, except we start with the consonants. So we have 3 consonants. And because this arrangement or this arrangement would work, we would add the 2. So the answer is 2 times 3 times 3 times 2 times 2 times 1 times 1. And that would give you 2 times 9 times 4. So that gives you 2 times 36. And the answer is 72 ways. And that would take care of our permutations with restrictions and repetition. So for extra credit, I'd like you to think about this. How many permutations are possible using the letters in the word All right, now this next problem can't be found in a typical algebra book, but I was thinking about that and I thought it was very interesting. Suppose we pick a 6-letter word that has repeating letters, like bubble. How many permutations can we make with all 6 letters? Well, the answer would just be 6 factorial over 3 factorial. Now, the next few problems have restrictions with permutations with repetition. So let's look at the B. B says the first letter is a vowel. C says the first and last letters are vowels, or are consonants, excuse me. D is the first and last letters are vowels. And E is that the first and last letters are B, the letter B. So let's look at these restrictions. If the first letter has to be a vowel, then the first spot, we've got 2 choices, either the U or the E. Once that's chosen, we have 5 letters remaining. So to permute those 5 letters would be 5 factorial, and we still have to take into consideration the number of ways we could permute the 3 B's if they were distinct. Now, if the first and last letters have to be consonants. So if the first and last letters have to be consonants, we have 4 consonants, the 3 B's and the L. So if the first letter has to be a consonant, there are 4 ways to pick that first letter. And then if the last letter has to be a consonant, then I'm left with 3. But because we use 2 letters from the word bubble, the number of ways to permute the word bubble would be the 4 factorial, because they're 4 letters, but we still have to divide by 3 factorial, because in these arrangements we're still permuting the B's. If the first and last letters are vowels, well, that's a little easier, because here there are only 2 vowels, the U and the E, and they're distinct. So the first place would be 2, the last place would be 1, and then in between we have 4 letters left, 4 factorial, and then we have to divide by the 3 factorial because we're permuting the B's. Okay, so I will leave part E for extra credit. How many 6-letter permutations can be made if the first and last letters have to be B? All right, that takes care of our lesson for today. Don't forget this is extra credit. And you could put that with your homework. I'll grade it. And have a wonderful day. Bye.